So in this video, we're going to continue our discussion of section 4.7, except now we're going to talk about some potential issues that could arise. And this stems from, in that first video, I talked about how there's actually lots of options when you come up with theta. There's lots of different choices, and so we're going to talk about that. Before we do that, though, I kind of want to motivate our discussion by reminding you all of another situation where this happens. And we're going to talk a little bit about the square root function here, because this is one you're all pretty familiar with. You've had to do a lot with square roots. So let's just say I had told you, I gave you a problem and I said solve x squared equals 100. Well, you might know right off the bat that x is 10. But if we were to actually show that using the square root, we would say, well, I know that x equals the square root of 100, and the square root of 100 is 10, so therefore x is 10. We could check that back in the original. We'd say 10 squared equals 100. However, there is an issue. When you take the square root of both sides, we actually know that both the positive and negative values work. If I check negative 10 squared on the calculator, I also get 100. So whenever you use the square root function, that little plus or minus sign pops up. And it's really important to remember that. Something similar is going to happen with trigonometry. So let's go back now to trig. So let's say I had said something like solve for theta. And the problem was, let's do sine of theta equals the square root of 2 over 2. And we'll stick to degrees because most of the solutions we get will be in degrees. So on this one, you might be able to just check the unit circle instead of using inverse trig. And if you did that, you would see that the y value when the angle is 45 degrees is the square root of 2. The x value is as well, but with sine, we're only concerned with the y value. So we would say, well, I know the answer. You'd say, I got it, Mr. Edwards. The answer is 45 degrees. And then we might say, well, what else would work? So if you continue going around the unit circle, we go over here. Whoops, that was too far. I was doing cosine there. If we continue going around the unit circle, and we pick this point, the x value is now negative. However, the y value is still positive. So you'd say, okay, well, this angle is 135 degrees, so there are my two solutions. And you would be correct if I said something like, find all solutions for 0 degrees is less than or equal to theta is less than 360 degrees. So basically one full rotation. We don't include 360 because that's the same as 0. But if you did one full rotation around the unit circle, you have now found all of the answers. If you go down here to the other square root of 2 spot, notice how they're both negative. So that doesn't work, and the same over here. So this is a really common statement, and this actually shows up in Delta Math a lot. You're done, you've solved it. However, there's actually infinitely many more solutions. So let me re-sketch this unit circle. We said that 45 degrees worked. Well, if I go around the circle one full rotation, I'm still in the exact same spot. This angle is coterminal to my original. This would be an angle of 360 plus 45, which is 405 degrees. And I'm still at the same location. And so this is also a solution. Since I did it once, I could actually keep doing it. So this would give me another one, etc. Additionally, instead of going in the positive direction, I could go the opposite way. I could subtract a 360. So I could go up to 45, and then I could come around this way and get 45 minus 360. And I could keep doing that. all of these work. So if I go to my graphing calculator here, sorry, my scientific calculator, and I said, well, what is, let's do sine of 45. That's square root of 2 over 2. You could double check that. I can say, well, what about sine of 405? Same answer. Sine of negative 315. Same answer. All of these solutions work. Just like with the square root, there were more answers than just the square root of 100. In this case, there's tons and tons of answers. And the way we represent that is we would say theta equals 45 degrees plus 360 degrees. And then we usually represent n to be as many times as we want. So in this case, n is an integer. You don't have to write that each time, though. We just kind of assume in these problems that n is an integer. So I'll write it the first time, and then we don't have to worry about it anymore. So there's one solution, when in reality this is actually infinitely many solutions. And then the other one would be 135 degrees plus 360n. So if I said find all solutions for 0 to 360, you would give me these two answers. If I just said find all solutions, then you would give me these. So let's do another example immediately just to kind of see how this would apply. Let's say we wanted to find, let's do solve for theta. So maybe we would have, let's do cosine of theta equals negative 1/2. Now this is another one. We're still on unit circle, so you don't have to worry about inverse trig yet. We will come back to that. But this is still a unit circle problem. So you take a look at your unit circle, figure out where x was negative 1/2. It should be over here. Which is 150 degrees. You could always go back and actually double check that. Oops, 120 degrees, I messed up. Good thing I double checked that. So that would be 120 degrees. And then the other one is down here. Maybe I should just double check this right away. At 240 degrees. So you'd say, okay, I found my two answers. So for 0 degrees is less than or equal to theta is less than 360. I get 120 and 240 degrees. If I wanted all solutions, I would have 120 plus 360 degrees n and 240 plus 360 n. And those would be our answers. So really, every single time you do this, you're going to get two solutions. Technically, there's infinitely many. But in reality, I'm expecting two solutions every single time, two representations of those solutions. And we actually do have some rules for these, just like we would with the square root. So what we can say is, for sine, the answer would be, if you were solving for theta, the answer is whatever theta you get, and also its supplement. For cosine, the answer is theta and then also negative theta. And then for tangent, which we haven't really seen yet, the answer is theta and then also 180 plus theta. So to see this, a really good thing to do is just to draw a picture. So for example, if I had some sine of theta and I got x and y, notice that this one over here, which is 180 minus theta, would give me the negative x and the y. So that's how you can see that the angle is also the supplement, so the y values are the same. For cosine, if I have some value for theta, so this was for sine, for cosine, then the same x value is going to be down here. It's just going to be a negative y, and that's just going to be negative theta. And then for tangent, tangent's a little bit harder to see, but if I had some theta here, and this was xy, if I rotate another 180, then down here I'm actually going to have negative x and negative y. So then y over x will still be the exact same thing, because negative y over negative x is the same as positive y over positive x. So these are the rules that you really need to remember once you get your answer, whatever it might be, to figure out what the other option is. Because once again, there's really only ever two solutions. Even though there's technically infinitely many, there's only two forms for your answer. And this is how you would get those two forms. So before I end this video, I know it's getting a little bit long. Let's just see how this would apply if we were using inverse trig functions. So let's say I said solve for theta. We'll do two examples. The first one is cosine of theta equals 5 over 13. And I'm going to say solve for theta, and I want all answers in this range here, 0 to 360. So this is not on the unit circle, and so that means we have to go back to the original topic, which was inverse trig functions. So we'd say, well, theta equals cosine inverse of 5 over 13. I don't have this off the top of my head. So let's go ahead and find cosine inverse of 5 over 13. 67.4 degrees. So theta is approximately 67.4 degrees. And let's go back to our rules. So we're in cosine, we get theta and we get negative theta. So the other option is negative 67.4 degrees. So if we were trying to find all solutions, we would say, well, the answer is 67.4 degrees plus 360n, and then also negative 67.4 degrees plus 360n. But I want the answer to be between 0 and 360, and this negative here is not between 0 and 360. So what I'm going to do is I'm just going to add 360 degrees to this to get a coterminal angle. So I end up with 292.6. So then my final answer would be theta is approximately 67.4 and theta is approximately 292.6 degrees. And we have just solved the problem. let's do another one. So I said we'll do 2, so let's do tangent of theta equals, oh, let's do 2. Let's do -2. No, I'll do 2. No, I'll do -2. Okay, so the answer would end up being theta equals tangent inverse of -2. Which is, if I can get there, tangent inverse of -2. So about -63.4 degrees. And then we said to find the other value for tangent, we just have to add 180 to it. So let's also add 180. So I get 116.6. So my solutions are these plus 360 degrees N. But I want to restrict myself to just 0 to 360, and that is not between 0 and 360. So we need to find a coterminal angle. So I get 296.6. So my two answers would be 116.6 and approximately 296.6. Okay. Again, sorry for the length of this video. I just wanted to make sure we saw a couple of examples before we ended. We'll have one more video, which shouldn't be too terribly long.